Hello everyone, I welcome you all and in this video we are going to discuss the numerical from unit number 1, that is vector analysis, and this numerical is basically related with finding the curl of a vector. Okay, so we will start with that, and if you have any queries you can drop me a mail onto my this email ID. Now we will begin with what is given to us and what we have to find out. Now within very first part of this numerical we are given with some vector A which is equals to xyz into ax plus ay cap. Okay, and we have to find what is its curl at the given point P. Now if you are going to simplify that one, so what you will have? So after that multiplication, that will be this xyz ax cap plus xyz ay cap. Okay, now we have this as your vector H. Now since this is the curl which has to be expressed in terms of that Cartesian coordinate system. So for that Cartesian coordinate system, we have the curl of given vector H, which is basically equals to what? It is a determinant of your this components along X, Y, and Z direction with this d by dx, d by dy, and d by dz. Now we are going to put what are the components along x, y, and z direction for your given vector h. So what we have? Component along x direction is what? We have the magnitude is equals to x, y, z. Now along ay we have the magnitude again x, y, z. And what is the magnitude along z direction? So we have that to be 0. Okay. Now this is what is your given vector curl of a given vector h and its determinant. Now we are going to simplify that determinant. So what will be that simplification? Very firstly, we are going to write that x cap as it is. Now this differentiation of y with respect to differentiation of this 0 with respect to y. So that is 0 minus differentiation of this xyz with respect to dz. So what will be that? So that will be simply, should I write for you? Okay, so fine. We will be writing it so that you will get into the details of this. And if you are expert with this, if you have enough practice with this, you can directly put the values of that differentiation. So for you can speed up this video and you can see that one if you know about how to solve that determinant. For some students, I am going to rewrite it again so that they will come to know how the answer is coming over there. Okay, fine. So we are going to write it again. Keep this ax cap as it is, then dy of that 0 minus this over here d by dz of that xyz. Then secondly we have that ay cap over there. Now what will be that one? So d by dz of this xyz over here, d by dz of xyz minus d by dx of this 0, d by dx of this 0 plus az into dabba. You can say this to be a dabba operator, but I am showing it to be d by dx. So d by dx of that xyz, d by dx of xyz minus d by dy of that xyz again, dy dy of that xyz. Okay. Now simplify that determinant. So after simplification, you will find this ax cap as it is. Now differentiation of this 0 with respect to y will be 0. Differentiation of this xyz with respect to z will be what now? That will be minus of xy plus ay cap. Now differentiation of this xyz with respect to z is what? We have that value to be xy. Then this second term will be 0 again. Then plus az cap. Then differentiation of this xyz with respect to x is what? We have that to be yz minus differentiation of this xyz with respect to y. So that will be what? That is xz. Okay, so rewrite that one. So you will find that del cross h for now will be what now? Minus xy x cap plus xy ay cap plus yz minus xz az cap. So this is what? This is the curl of your given vector field, vector h, for your Cartesian coordinate system. Now next thing is what? We have to find out what is that del cross h at given point P. Now we have to find out the curl of a given vector h at given point P. So simply we are going to put the values of that x, y and z within that your curl that we have found. So what value we have for that x? So we have that x to be minus 3 into that y is equals to 2 into ax cap plus again we have to put the value of that xy. So xy is what we have, that is again 3 into 2 ay cap and then plus yz. So what is that yz? This y into z is again 2 minus xz is what we have, x into z. So that is 3 into 1, that is 3 into az cap. Now from this you will find the value of the del cross h at given point P, and that is equals to minus 6 ax cap plus 6 ay cap minus az cap. So this is our final answer for your part 1 of the numerical. Now we will move on to the second part of the numerical. Now in the second part of this numerical we have to find the curl of a given vector which is equals to rho phi and z. I have taken it from your question paper. It is given to be E, but it is not E over there. It is what? It is rho phi z az cap having the coordinates at point Q which is equals to 2, 30 degrees and 3. So that shows you what? That shows you this rho is equals to 2, this phi is equals to 30 degrees and this z is equals to 3. Now we are going to find out what is the curl of a given vector H. Now since we have that your vector H in terms of what? In its cylindrical coordinate system. So we are going to write what is the curl for that cylindrical system. So we have that is equals to this 1 upon rho out of the determinant having the components along a rho, a phi and az component with respect to d by d rho, d by d phi and then d by dz. And what are its magnitude? So magnitudes of your given vector H. So generalized form is this. We have that to be arrow. So that shows you what? Magnitude along that rho phi and z direction. Arrow a phi and a z direction. But still it is not correct. Why is that one? Whenever we have the phi component, so that phi component is associated with its radial component. That is what? Your rho factor over there. So always keep in mind, very firstly you just write this 1 upon rho out of the bracket. Then you just write the generalized form, that is a rho a phi and a z, d by d rho d by d phi and d by dz, and again a rho. So that shows you what? Magnitude of your say for now given vector A. So if you are given with vector A in terms of its cylindrical system, so it will be expressed like this one. Okay, so this shows you the generalized form of your given vector if it is expressed in terms of its cylindrical system. Okay, so this is the generalized form. Now we are going to put our values for your given vector H. So keep this 1 upon rho as it is. Now that arrow, then we have the second term, that is rho a phi, and we have this to be what? A z. Then this will be as it is, d by d rho, d by d phi, and d by dz. Okay, now let me rub it. This shows you the generalized form of your given vector. Now for our given vector H, what we have? We have, what is the component along arrow? So we have, is there any component along that arrow? No. Why is that one? If it is expressed in terms of that arrow and a phi and a z, so you will find this, that there is zero component along arrow direction, there is zero component along a phi direction, but there is component only along the az direction. And what are that components? That is rho phi and z along az direction. So we are going to put that one. We have that very first arrow is equals to 0, component associated with arrow is equals to 0. Then we have that to be a phi 0, and this finally we have the component associated with az direction, that is to be rho phi and z. Okay. Now we are going to simplify that determinant. So well, I guess you will come to know about that one from our previous slide. Okay, so this will be quite lengthier one. So we'll be writing it over here. So keep this 1 upon rho as it is. Now we will simplify that one. So very firstly, this will be your arrow cap. Now next, d by d phi of your rho phi z. This one over here, d by d phi of that rho phi z minus d by dz of 0 plus, what is the second term? We have this rho into a phi, rho into a phi cap. Then this d by dz of 0. See, don't mind for these curly lines. My handwriting is not good. Okay, so d by dz of this 0, d by d rho, d by d rho of this rho phi and z. Then we have this az component. So we have this az component, and this d by d rho of 0 minus d by d phi of this 0. Okay, now we are done with this. Now just simplify that one. So after simplification, keep this 1 upon row as it is for now. Okay, so what you will get from your very first square bracket? So d by d phi of rho phi z. So that is what? That will be equals to rho z. Now this will be 0. So I am not going to write that one. Now keep this row into a phi cap as it is for now. Now we have this to be 0. So I am not going to write that one. D by d rho of that rho phi z. So we have that value to be what? Phi of phi into z plus az cap. And az cap it is all of the terms over there are 0. So that term will be 0. Az term will be 0. So we have this to be equals to what now? 1 upon rho into rho z a rho cap plus rho phi z into a phi cap, and this az is 0. So if you are going to multiply this 1 upon rho within this bracket, so what is left? So left is only this one, z into a rho cap minus phi z a phi cap. So this is what? This is our curl of a vector h in the cylindrical system. Now next thing, we have to find out what is the del cross h at given point q. So we are going to find that one. Now we have to find that del cross h at given point q having the coordinates of 2, 30 degree and 3, which is equals to what? Now simply put the values of that rho phi and z in the equation that we have found. So we have that del cross h is equals to z into a rho minus phi z a phi cap, and if you are going to put that values over there, so you will find that 3 into a rho minus phi is, we have that to be 30, and this z is again 3, and this a phi cap. So we have that del cross h at given point q, which will have this value, that is 3 a rho cap minus, sorry, not 30, it should be 90. It is a 90. 30 into 3, that is 90. 90 a phi cap. So this is our final answer for your this numerical. Okay, so you can appreciate my efforts by hitting the like button. Thank you.